Final view shows completed pantograph ready for installation, gleaming in factory.
Capacity efficient.
The current capacity looks good, but we need to optimize the contact forces at high operating speeds.
I agree. The
Pantograph principle now explains the loaded mechanism, maintaining contact with the overhead wire.
Single-arm design develops streamlined structure, reducing aerodynamic drag at high speeds. Modern single-arm pantographs provide equivalent
Double-arm heritage explains traditional symmetric design, providing redundancy and balance. Classic pantograph architecture offers contact strip material selects carbon or copper alloys, balancing conductivity against wear resistance. Carbon strip manufacturing produces composite materials mixing carbon with metal particles. Sintered carbon-based strips offer excellent wear resistance.
Frame welding joins components using robotic equipment, ensuring consistent quality. Precision automated welding creates
Spring assembly constructs mechanisms maintaining contact force against overhead wire. Carefully calibrated springs apply vertical system integration. Install the elements isolating contact strip from sophisticated suspension maintains smooth wire contact.
Base hinge fabrication produces robust mounting attaching pantograph to roof. Heavy-duty base
electrical insulation installation isolates energized components from grounded vehicle structure. High-voltage insulators prevent dangerous electrical
Composite insulator integration uses polymer materials offering lighter weight and vandalism resistance.
Current collection horns install conductive connections, transferring electricity from pantograph to vehicle. Braided copper cables flexibly connect.
Flexible cable construction builds multi-strand conductors accommodating continuous pantograph motion. Highly flexible cables withstand millions.
Arc suppression system and position devices minimizing parking and during contact interruptions.
Wear monitoring sensor integration, devices measuring contact strip remaining thickness, continuous.
Accelerometer mounting measures vertical acceleration, detecting bouncing or instability. Vibration monitoring identifies dynamic problems requiring adjustment or indicating worn components. .248.31 Heating element installation embed resistors melting ice friction on contact strips.
Lightning protection integration installs surge arresters protecting against atmospheric electricity. Lightning protection safely channels strike.
Make sure that clamp is fully secured.
It's tight. Reading nominal voltage now. We are fully grounded.
Static force testing measures spring characteristics and contact pressure accuracy. Calibration testing in
dynamic testing operates pantograph against moving wire, simulating operational conditions. Test tracks with catenary validate performance at various speeds and wire heights.
Score 248.39. High-speed evaluates Slayer's performance at ring point of gate. Current collection testing measures
Wear rate evaluation measures strip material loss under controlled conditions. Accelerated wear-to-wear life.
Vibration testing subjects pantographs to simulated track irregularities. Dynamic testing validates.
Environmental testing exposes pantographs to temperature extremes and moisture. Climate chamber testing confirms performance across operational temperature range and weather conditions.
Isocriticity, Baltasic testing, adaptive revisif actual belt. Current testing, arbor testing at Artisan curve.
Life field applies for lighting protect surges. Fab ID deceptive surges light for zipking.
Check the tolerance here on the collector head.
Already done. It's well within spec. We're clear for shipment.
Dimensional verification measures critical features ensuring proper fit and function. Precision measurement confirms Material certification documents verify component materials meeting specifications. Comprehensive material.
We've done the self-conduct testing conformance specification outlined in section 40.
The results are satisfactory.
Technical documentation provision supplies installation instructions and maintenance procedures. Comprehensive manuals support proper installation and ongoing care throughout service life.
Ensure the mounting is secure before applying the torque wrench. We need to reach exactly 50 Newton meters for safe performance.
Carefully align the new carbon strip and use the torque wrench. The specification is 248.53.
Understood. Applying torque now.
We have a critical pantograph failure on line 3. Initiate the retraction sequence now.
Retraction sequence confirmed.
248.55. Spare parts provision establishes inventory supporting maintenance requirements. Adequate parts availability ensures rapid strip replacement, minimizing vehicle downtime.
We've addressed the unusual wear pattern you reported. The data confirms the new guides are ensuring optimal performance now.
Excellent. That resolves the issue.
Warranty coverage protects against defects and premature failures. Manufacturer guarantees build confidence while continuous improvement analyzes field experience, refining designs and materials. Systematic failure analysis. Standards compliance ensures pantographs meet international specifications and railway requirements. Adherence to
248.16. EN standard conformity validates European norm compliance, enabling sales throughout continent. European standard year.
248.61. IEC specification adherence follows International Electrotechnical Commission standards. Global
Railway-specific requirement adapt designs to individual operator
high-speed applications demand specialized designs for extreme velocities. Pantographs for bullet 248.64. Heavy freight unstudded strengthened components for intensive continuity.
Metro applicative designs, urban transit pantographs fit tight loading gauges while providing reliable performance.
Tram pantographs employ simplified economic designs for limited operations. Street running requires
Multi-able
248.70. Wide gauge modifications accommodate Russian and Indian broad gauge systems. Specialized
Vibrated grappling, vibrated router above decent and reduce of richer. Isolation brass and pantograph oscillates right
248.75. Reliability achievement demonstrates mature technology providing dependable current collection.
248.776. Maintenance optimization reduces servicing requirement.
Predictive maintenance ratio enables condition-based servicing, replacing time-based schedules. Sensor data guide. Invention. Lifecycle cost analysis evaluates total ownership expenses guiding design decisions. Comprehensive economic
Lightweight materials research explores composites, reducing pantograph mass. Weight reduction improves dynamic performance and reduces vehicle roof loading.
Smart materials investigation examines adaptive structures adjusting properties automatically.
Nanotechnology application explores enhanced contact materials, improving conductivity and wear. Nano-engineered wireless power transfer research investigates contactless current collection, eliminating wear. Inductive or capacitive coupling promises eliminating mechanical contact.
Require enhanced reliability of silver's liabilities to demand fail-safe date.
Sustainability focus emphasizes recyclable materials and extended service life. Environmental responsibility.
Circular economy principles promote component remanufacturing and material recovery. Sustainable business models extend component life, reducing waste.
Carbon neutrality goals drive reducing manufacturing emissions and improving efficiency. Environmental commitments require reducing.
Global market serves railways worldwide, adapting designs to diverse requirements, international sales, demonstrate manufacturing.
Export success generates foreign exchange through international pantograph sales. Successful global marketing
Competition intensity drives continuous innovation, maintaining market position. Competitive pressure benefits railways through improved performance and reduced costs.
248.95. Economic contributions of skilled manufacturing employment producing specialized components. Pantograph production provides stable jobs supporting communities hosting facilities.
Technology leadership establishes reputation for innovation and quality.
Professional recognition earns industry awards for engineering excellence. External validation enhances reputation and employee pride in achievements. Customer partnerships build long-term relationships spanning decades. Trusted supplier status creates knowledge preservation, documents expertise, supporting continued capability. Systematic knowledge management prevents loss through workforce transitions.
Ensure the torque is set correctly for this joint.
Yes, calibrated to the specifications for the upper horn assembly. This ensures optimal contact stability.
If we adjust the thrust vectoring here, it solves the oscillation issue.
Yes, that improves the atmospheric reentry profile significantly.
We need a creative solution for these stress points.
Continuous improvement means addressing these emerging requirements now, perhaps adjust the carbon fiber mix.
We've ensured every page is meticulously preserved,
both physically and digitally.
The
Safety culture prioritizes reliability, protecting passengers and workers. Commitment to excellence prevents failures, maintaining public trust.
Historical appreciation acknowledges pioneers developing early current collection devices. Recognition of innovators who enabled electric railway development.
Adjusting the carbon contact here reduces aerodynamic drag at high speeds.
We found a similar principle applied to the T248.108. Standards participation contributes to specification development. Active involvement shapes requirements, ensuring products remain compliant.
If we adjust the parameters here, the efficiency increases exponentially.
Incredible. We finally have the proof of concept.
Technology transfer shares expertise with partners and customers. Knowledge sharing supports domestic capability development in emerging markets.
By using this control panel, you can manage the signals and switches across the entire network, ensuring safe passage for the trains.
Public appreciation recognizes invisible technology enabling electric railways. Increased awareness builds understanding of specialized engineering.
Infrastructure enablement acknowledges pantographs essential for electric railway operations. Recognition of critical components enabling sustainable transportation.
Environmental contribution supports zero-emission electric railway operations. Reliable current collection enables clean transportation, reducing pollution.
Economic enablement recognizes pantographs facilitating efficient railway transportation. Reliable power collection supports railway competitiveness and productivity.
Social benefit acknowledges supporting sustainable mobility for millions. Pantograph technology enables environmentally friendly mass transportation.
Quality of life improvement provides comfortable, reliable railway service. Dependable current collection supports punctual operations, improving daily commutes.
Urban sustainability enables clean, efficient metro and commuter operations. Reliable pantographs support urban transit, reducing automobile dependence. Climate action contribution supports transportation decarbonization through electrification. Pantograph technology essential for zero-emission railway operations. Future readiness anticipates continued railway electrification worldwide. Strategic planning planning ensures capability serving growing electric railway demand. Global electrification trend creates growing pantograph demand. Worldwide railway electrification expansion supports continued industry growth.
High-speed rail expansion.
Urban transit growth drives metro path demand. Urban rail expansion, particularly in the substantial
freight electrification potential promises future market expansion. Eventual freight railway electrification could significantly expand pantograph market.
Innovation persistence continues advancing mature technology. Ongoing improvement demonstrates commitment to excellence, continuously enhancing performance.